Here you can see a typical Voltaic or galvanic cell, and you know enough about it to know that atoms of zinc anode are getting oxidized, they are losing electrons. Electrons are running through the wire towards a cathode where they are reducing copper ions. Okay, this entire process is happening spontaneously. We are not doing anything to initiate this process. It is happening because zinc is active and is likely to lose electrons, and copper is less active and more likely to accept electrons and provide the place where copper ions will be reduced. So this entire reaction is happening spontaneously. But it's not the only way to run the electrochemical cell. There is a different type of electrochemical cells called electrolytic cell, and here's one over here. As you can see, there is a battery installed in it. So, battery over here is installed with the purpose of providing energy to initiate non-spontaneous chemical reaction. In electrolytic cells, we are running chemical reaction that without our interference would not be happening at all. But we are putting in battery or any kind of source of electricity to initiate a process, to run a process that would not be running otherwise. Now let's take a closer look at this type of chemical cells. Electrolytic cells, they are electrochemical cells that require energy. They require electric current to force a non-spontaneous chemical reaction. In Voltaic cells, we were getting energy to ourselves as a byproduct of spontaneously running chemical reaction. Over here, we will have to spend energy to run this non-spontaneous reaction. Electrolysis is a process which occurs inside of the electrolytic cell. It is a process in which electricity is used to force a chemical reaction to occur. It can be used to electroplate metals on a surface of other objects made out of metal. Let's take a closer look at how it works. Here is a typical electrolytic cell. There are two electrodes, this aluminum spoon on the right and silver electrode on the left. If we take the table J, an activity series of metals, we will see that aluminum is more active and silver is less active. So our expectation would be for atoms of aluminum to be oxidized and silver electron behaving as a cathode, providing a place for reduction. But this is an electrolytic cell. Here we installed a battery, and battery will be acting as a pump that is pulling electrons away from the silver electrode, forcing the silver atoms of the electrode to be oxidized, to be losing their electrons. The battery will be pulling electrons away from the silver and sending them in the opposite direction towards the spoon. Energy of the battery is needed to reverse the flow of electrons. By pulling on electrons of the silver atoms in the electrode, the battery is forcing atoms of silver to be oxidized. And by sending those electrons towards the spoon, it forces a spoon to act as a cathode, to be a place for the reduction. So now a silver electrode will be the place of oxidation. It is an anode. And the spoon will be the place of the reduction. It is a cathode. Let's write the oxidation half reaction that is taking place on the silver anode. The atoms of silver are losing their electrons due to the pull of the battery on them, turning themselves into the silver ions. Positively charged silver ions become part of this solution. Those electrons that battery is sending from the silver electrode to the spoon are arriving to the spoon, charging it with the negative charge. A bunch of electrons arrive to the spoon, and now spoon has a negative charge altogether. Positively charged ions in the solution will be attracted to the negative charge of the spoon. They swim across this beaker and arrive to the surface of the aluminum spoon, where they will get reduced and turn themselves into atomic silver and stick to the surface of the spoon. Over time, the entire length of the spoon will be covered by silver atoms. It is as if we painted with the silver atoms the entire spoon. So our cheap, not so shiny aluminum spoon will be looking as if it is made of silver. Silver atoms are getting oxidized on the silver electrode, and silver ions are getting reduced on the aluminum spoon electrode. Electrode on the left is a site of oxidation. We call it an anode. The electrode on the right is the site of reduction. We call it a cathode. Nothing is really changes about our definition of electrodes. It is still the sites of oxidation and reduction. Anode still a site of oxidation, cathode is still a site of reduction. However, in electrolytic cell, since we are pumping bunch of electrons towards the spoon or towards this cathode on the right, we're giving this cathode a negative charge. So in electrolytic cell, cathode is negative and anode considered to be positive. There are certain similarities that we have to underline between the galvanic and electrolytic cells. Both of them are using redox reactions. In electrolytic and voltaic cells, anode is the site of oxidation and a cathode is a site of reduction. And electrons flow from the anode to the cathode willingly or unwillingly. However, there are certain differences. The redox reaction in a voltaic cell is spontaneous, while in an electrolytic cell, the process, the redox reaction that we are running is a non-spontaneous. It would not be occurring unless we provide energy for it. Voltaic cell does not need energy investment. In fact, we can get energy out of it, and we often do in batteries and such. Electrolytic cell requires a power source to operate. And in voltaic cell, the anode is considered to be negatively charged and cathode is positive. In electrolytic cell, the signs are switched. The anode is positively charged and cathode is negatively charged. Still, the flow of electrons in electrolytic cell or voltaic cell will always be from the anode to a cathode. Let's try to use this diagram to answer all these questions. We were given information that the oxidation takes place on the nickel electrode. So nickel electrode will be anode, and the spoon will be playing role of a cathode. Since there's a battery, it's electrolytic plate, so we expect our anode to have a positive charge and a cathode to have a negative charge. The electrons will be running from the anode to a cathode. Let's write the oxidation and reduction half reaction. On the nickel electrode, atoms of the nickel will be oxidized. They will be losing a couple of electrons, turning themselves into ions, positively charged ions of nickel. Those nickel ions will be attracted to the negatively charged cathode, our spoon. They will be traveling across the beaker and eventually arrive to the spoon where they will be reduced. They will accept a couple electrons and will be reduced into atomic nickel that will accumulate at the surface of the spoon. Positively charged ions will be attracted to a negatively charged cathode, and negatively charged ions will be attracted to the positively charged electrode of nickel. Atoms of nickel are getting oxidized. Ions of nickel are getting reduced. Let's see if we can answer this set of questions. We are given information that when this cell operates, oxidation occurs at the silver electrode and mass of the silver electrode decreases. Well, that settles it. Silver electrode is an anode. And since we have a power source here, it is electrolytic cell, we can say that this anode is positively charged and Ki plays role of a cathode and it has a negative charge. The role of the power source is to pull on electrons of silver atoms, forcing the silver atoms to get oxidized, and pull those electrons away from the silver electrode and send them towards our cathode, nickel. As time goes by, more and more atoms of silver will be oxidized, turning themselves into ions of silver and becoming part of the solution. So the mass of the silver electrode will be decreasing because there will be less and less atoms in it. and the concentration of silver ions in the solution will be increasing. Those positively charged ions will be attracted to the negative charge of the cathode. They will be attracted to the key, and they will reach the surface of the key where they will get reduced into the atomic silver, and they will stick to the surface of the key, thus increasing the mass of it. And the last questions, well, electrons always will be running from the anode to the cathode. So they will be traveling from the silver electrode to the battery, through the battery, and towards the key. So pretty much atoms of silver are getting oxidized, turning themselves into positively charged ions of silver. Positively charged ions of silver are attracted to the negatively charged cathode. And on the surface of this cathode key, they will be reduced into the atomic silver, covering this key with the nice layer of silver atoms. So our key will look like a silver key, but we would know that actually inside of it, it is a very inexpensive nickel key. Apart from making shiny keys and spoons, we can use electrolysis for obtaining active elements such as sodium and chlorine. We can do that through electrolysis of molten salt. The molten salt is a salt that was liquefied at a high salt that is normally solid at a very high temperature can become a liquid. In molten salt, ions of the salt are separated and they can move. So if I stick two electrodes inside of my molten salt and with the help of the battery will create a positive charge on the anode and a negative charge on the cathode, I can expect my negatively charged ion traveling towards a positively charged anode and positively charged sodium ions traveling towards a negatively charged cathode. On the cathode, the sodium will be happily reduced into the atomic sodium, and chloride ions will be oxidized into the atomic chlorine, losing their extra electron and combining themselves into diatomic molecule of chlorine. 2 electrons are lost, 2 should be accepted, so we need to adjust our reduction half reaction for sodium as well. And voila! Through this process we were able to obtain pure sodium and chlorine, elements so active that it's actually very difficult to get them uncombined. I hope that you can see now that electrochemical cells have a wide range of applications, and I hope you enjoyed learning about them.